gentlemen, we are going to go ahead and get started. On my to-do list, a lot of your eyes went right down to the bottom, and I just want to let you know, I want to make this really, really clear. So I am going to move the test from, it was supposed to be tomorrow, I'm going to move it to Friday. The big reason for that is because I felt like after our conversation yesterday, some of us were feeling great, and some of us were kind of like, I don't know. So we're going to move on to some other stuff tomorrow. Like, it's not all going to be packed in there, but I do want to go over some homework tomorrow, and I also just want people to feel good. Does that make sense? Okay. The conversation I had during passing time, I do want to tell you this also. There were people who were like, oh my gosh, I was supposed to have 3 tests yesterday, so that's awesome, or tomorrow, so that's awesome. Here's the thing. I only have one section of you all, okay? If there is another big test, or there's like a stack of tests that's coming up on the same day, I can be flexible. I can move things, and I would much, much rather, especially since we're so late in the day, like if you had to study for and had taken a bunch of tests already, your brain's going to be fried. You're not going to be ready for this test. And then I have to grade tests that are not good. And that is like, that's not good for anybody. So this is what I'm asking from you. If there's a situation where you're like, whoa, I'm going to have like 17 tests on one day, talk to me. Usually what we'll do is move on to new material and just push the test back by a day. But I'm totally good with that. Does that make sense? You just got to talk to me. That's all I need. Okay. So today we are going to talk, we're going to kind of try and wrap this stuff up, make a little more sense, because I think that I kind of jumped in without, like, I feel like I was writing a 5-paragraph essay without the thesis statement. So I'm going to go back now and actually give you the thesis statement so that we're all clear. Okay? Thanks. Yep. After that, we're going to do a little bit of kind of reviewing of our forces. We're going to do a little bit of focusing on friction. I guess that's a little alliteration, but it's actually important. And then do some graph matching. You may have already done this homework. I don't think so, though. If you did, cool. If you haven't, I really don't like to talk over people that are talking. It really drives me nuts, so please stop. If you haven't done this homework, please do it for tomorrow, okay? We'll talk about it. There's a lot of, I looked at this, and it's a lot of tension problems, strings, but I think a lot of the things that we're doing today are going to make a little more sense, okay? And then again, we're going to do our Unit 1 test on Monday. That all said, I know that it's coming up not tomorrow, but the next day, but I do want to tell you what I have on my list of things when I'm going to write this test this weekend. So you may want to write this down just to kind of help you focus your studying, focus your, oops, that's frozen, so you can't see it. Focus your attention. Okay? The things that I will be looking at as I'm writing this test, definitely graphing. Definitely drawing best fit lines and calculating slope. One thing that we have not yet talked about is doing these sorts of things for something other than distance versus time graphs. Okay? I'm going to let you know right now, so I don't want you to focus down here, I want you to listen to what I'm saying because this is important, okay? And I think I may have said this already, but I'll probably say it a bunch of times too. In AP Physics, like on the exam, they like to throw at you some crazy weird physics content that you have never seen before. I think maybe I told you this before, okay? So I'm probably going to do that also. But this is, the reason I'm doing it, it's kind of like, the more you practice it, the easier it feels, right? So we're going to do it. It's going to be stuff that doesn't make sense, but if you take a deep breath and step back, oh, there are numbers, and I need to graph them. And there are units, and I'm going to draw a best fit line, because I can do that regardless of what these things are, right? It could be magnetism, it could be quantum mechanics, it doesn't matter, because they're numbers and I know how to graph them. I know how to find a best fit line, I know how to find a slope. You with me there? We've practiced that a bunch of times. You know how to do that. So that's what we're playing with, okay? That's the graphing stuff. Non-accelerating motion problems. What does that mean? It means velocity is distance over time. You've got that. We've practiced those. I think you're okay, but I just want to make sure you know that. Certainly an opportunity to draw some free body diagrams on your test or to look at some free body diagrams. This is stuff that we're going to practice today, so I just want to make sure you know that. Writing F-net equations. What does that mean? Okay. Trying to process through that. And then finding values for gravitational, normal, and frictional forces when F net is 0. Okay? This is the list that I'm going to look at when I write the test. So it might be also a list that you want to look at when you're studying for a test. Okay? I don't like to throw big curveballs, but I also think that in AP Physics, as it should be in the course, but also because we're, again, getting you ready for the AP exam, it's not going to be verbatim, oh, we did this problem in the book, so I'm just going to change the numbers. Like, that's not how we roll, okay? But that's what I'm looking at. Questions about this list before I move on? I can post this list up on Canvas too, so you can see it there as well. Okay. All right. Let's go. We're going to talk about non-accelerating motion. So we're kind of like, again, thesis statement. So you might want to write this down. This would be a good thing to kind of like have in your head. So our topic, this whole unit, you may have seen the labels. I'm not sure. The label is non-accelerating motion. And even though I promised you a few days ago that I wasn't going to use that A word, I'm going to use it a lot today. Because I was realizing as I was thinking back through our conversations the last couple of days that maybe by tiptoeing around it, I was actually doing you a disservice. So I apologize for that, if that was confusing. So I want to articulate and say, what is non-accelerating motion? What does it mean for something to be moving and not accelerating? Question mark. Go.
The velocity remains constant.
Yeah. Awesome. It means also then, kind of from that, I'm just going to take next thing and I'm going to run with it. It means from that we can predict how far something goes over a given amount of time if we know the velocity, etc. You can kind of put those together. If something's not accelerating, does that mean that there are not forces? Can we still have forces acting?
Yes.
Absolutely, we can still have forces, yes. Objects do have forces acting. But the key for non-accelerating motion is that all of the forces must add to what? That's right. Okay. I need to go grab a basket. Oh, right. This room is kind of crowded. We're going to do this right up here. Harrison, why don't you stand up?
Ball's like.
And I'm going to have you move your bag. Harrison and I are going to do some ball rolling right across this front area on the floor. So scooch back a little bit. There you go. So if you can't see the ball when it's on the floor right here, then you probably want to come up here, come look around so that you can see. There's not a lot of room, but we're going to be okay. So there are 4 cases, 4 situations that we're going to look at. I'm going to demo it, and then we're going to draw it on the board. But I just want you to have this in your head. We'll do it a couple times. All right. We okay? It's going to go right here. So there you go. Can you see now? It's all good. All right. You ready?
Yeah.
Okay. So we're looking at the ball. We're paying attention to what's happening with the ball. Again, I said there are 4 situations. We're going to call this one A. Okay. B, C, D. Yeah, bring it back. We'll do it one more time. It's not wild and crazy. There's not a lot not a lot of unpredictability. Then we're just going to do it. So we got A, B, C, D. Got it in your head?
Yeah.
Okay, now go back to your seats because we're going to draw it. Thanks. It was pretty exciting. Thanks for, I know, it's super flat. But it rolls, so that's what I usually do.
Probably doesn't bounce very well.
It does not. For better or worse. All right. Here we go. So this is, we're gonna say there are, we'll just say basketball. All right, so on your paper, here we go. We're gonna draw the 4 cases. So we've got A, we've got B, we've got C, and D. I would like for you, in each of those cases, to tell me what forces are acting on the ball. By that I mean draw a free body diagram of the ball in each of those cases. Go ahead and do that. Okay? You and your brain, we'll start there.
Bless you.
I want you to draw a free body diagram, so do it all. Good practice, right? If you don't practice it, you're not going to do it. Okay? Your coaches say that. Your instructors in music say that. I know they do because it's so true. If you don't practice it, you're not going to do it once it comes down to the time you need to.
Okay.
I was just going to say, if you have not started talking at your tables, go ahead and do that. Have a conversation. Check with your tables.
No, they're new stuff. Oh yeah.
Sorry, I didn't mean to make that land on your hands. That was kind of weird. All right. I hear some really good physics-y conversations going on. That makes me super happy. Yay. Would you please, on your whiteboard, draw for me the free body diagram of A?
I almost got her to that one.
F and for
Extended tardy. Jacob, we really know how many careers in they're mostly just church musicians. They pay like $10,000 a year. Wait, can you touch me? It's not a living. You guys work at like 6 different churches.
All right. How are we doing? Do you need another minute or are you good? All right. Would you please send the person that is to the left of the person that drew it? So whoever drew it, the person to the left of them needs to come up to the front so we can take a look at these real quick.
Let's go.
Come on up.
Can we use Epic? Okay. Is it for some cartoon? Yes.
All right. Quick.
We're gonna get right A in the circle like everyone else.
Don't worry.
he's gonna have
He's close.
to write. You have
No.
Ready for ball.
That works. I mean, that's
All right.
B for ball.
Let me see your free body diagrams. I just want to take a peek. It's much easier to see this, and then you all can see it as well. So you all have. So we're playing the game. What is similar between these pictures? What's something that you see that's similar, friends that are standing out here? There are circles. Yes.
Like a ball.
Circle for the bars. There are 2 arrows. In each case, we have 2 arrows. That's great because there are 2 forces acting on the ball, right? Got one that's pointing down. And that one's going to be labeled the force of the earth on the ball. Yeah? And then if you put in parentheses FG, that's absolutely fine. You didn't have to. And then there's one that's going up, and that's the force of the floor on the ball. And then we label that FN if we want. Cool. There are a couple little things that I'm going to talk about in just a second, but you guys can go sit down because those look lovely. Thank you so much. Nice job.
Fixed it. Look, I fixed it.
All right, so a couple of little pieces here that I want to make sure that you're listening to. This is something that I forgot to tell you last time when we were doing free body diagrams, but I want to make sure that you know now, okay? Please listen. On AP tests, when they ask you to draw a free body diagram, they don't usually give you a ball, they give you a dot, and they say draw the free body diagram of the dot. This is one of the most ridiculous rules that you have to follow as an AP grader, an AP reader, but they're really picky about it, which is why I'm telling you, okay, so that you know, the arrow has to touch the object. It's really ridiculous. Like, seriously, no, I'm not kidding you. I've had to, take points off of people's, grade, their score, because the arrow doesn't touch. So, make it touch. It's not hard, right? Use a little extra graphite, make it work. So, make it touch.
Look at that guy.
All right. Ladies and gentlemen, let me have your attention up here. We don't need to pause for 20 minutes after each thing I say. Otherwise, we're not going to get through all this today. All right. The other thing that I noticed that I wanted to point out is that the arrows have to come from the object. So it's really important, and a lot of people want to do this. They want to put this arrow up here pointing down. And then this one down here pointing up. You understand what I'm saying? Okay? So I just want you to get in the mentality. It's kind of like if you imagine yourself, or you imagine the object as part of a tug of war rope, okay? And the things are pulling on it in both directions, okay? So you have the object, and then the forces are coming out from it. Okay, so that's really important to know. Cool. All right. We'll come back to the rest of it. No, we'll talk about it right now. Tell me about the motion in A. What was the motion in the ball for A? Nothing? So you could maybe say that the velocity was equal to 0? Yeah? And tell me what you notice about these forces. What do you think they might add up to?
0.
Yeah. Awesome. All right. Talk to your table mates. Do B. B was when I was pushing the ball. The force of carbon on ball. Or something.
Okay, C for circular. Marker 7. Still true.
Describe a lander.
Yeah, it's pretty opaque. That's mine. All right, we're gonna That's not. That's the one.
I heard my name. Who had a question? You good? We ready?
We're talking about
When I'm actually I'm in contact with the ball. Yes. Yes. Put your phone away, please. You do not need your phone now.
Okay.
Put it away.
Yeah.
Why did you erase the whole? Okay, so this is right. We got it.
FT. Ah.
All right. How are we doing here, team? Let me see your boards. You don't have to come up. Just hold them up for me. Let me see. All right. It's okay. You guys are fine. No rush. Cool. All right. Okay. 1, 2, 3, 1, 2, 3, 1, 2, 3, 4. Awesome. Put them down. All right. So there's always a debate when it comes to letter B. There's not a debate about the earth. The earth is definitely pulling on the ball. It pulls down, right? The force of the earth on the ball. There's for sure the force of the floor on the ball. There's also definitely a force of me on the ball. What kind of force is that, by the way? That's an applied force. Awesome. Then there's always a question about whether or not there's friction. So here's the thing. Please don't waste my markers by writing on people. That's weird. Please don't do that. All right. The question is whether or not there's friction. So here is my grand statement about whether or not there's friction. When you're working on a problem, if it doesn't mention friction, and you don't need friction to make the problem work, you know what I'm saying? Let's assume there's no friction. Let's keep our life easy, right? Assume no friction. We want to get rid of it. Now, if there is friction in this problem, which way would it be going? This way, right? It's going to be going opposite. It's because it always what's motion? Opposes. So you can put that friction in if you want. The force of the floor on the ball, FF. I do know that the ball is moving this way, so I know that this one's got to be little. You with me there? Little compared to this one. Otherwise, it would be going backwards, which it's not. So if you had the friction on there, cool. If you didn't, that's okay too. Okay? Tell me about the velocity in this situation. As I'm pushing the ball. It's what? Greater than 0. It's not 0, and is it constant?
Yes. But no, it means acceleration.
As I'm pushing on it is not constant. So its velocity, I'm going to say, is increasing. I could also say that it's accelerating. And what do I know about the net force acting on it, friends? It's greater than 0, or it's not equal to 0, or something like that. For letter C, I am going to now ask that you imagine that instead of a basketball rolling on this floor, I had a bowling ball, okay? And that bowling ball was sliding down a bowling alley lane. By doing that, what am I trying to eliminate? Boom. Okay. So in C, we're going to imagine that there is no friction. Go ahead and talk to your table mates. Draw that on the board. No friction is acting.
Yeah.
The dog.
So there's no real. If you wanted to, you could put pressure on this one.
Jasmine, would you still?
The other one too.
Because it's not.
I was working. But that was
Yes.
Mine's not connected.
It is connected.
That's a white line.
That's not touching that.
Just to be clear, ladies and gentlemen, I want you to think back to when I was here pushing on this ball and Harrison was standing over there. I said A, I wasn't touching it, right? B, I was touching it. C was when the ball was definitely somewhere between Harrison and myself. Nobody was touching the ball. Okay? And as much as we like to pretend like our world is Star Wars, it is not. So I just want to make that clear. So nobody was touching the ball. Harrison wasn't like, you know, I mean, like maybe you have a power. I don't know. Do you? Are you that cool? You're not aware.
Are we assuming this floor is level?
An object.
It's not.
Pretty dark. Much closer than that.
Miss Ellison's room is not level. We did a marble lab in there, and it was horrible. You had to roll marbles, and it was just like.
I don't even know what it means, but
But
okay.
like they were.
All right, let me see your boards. Let me see them. Put them up. Put them up. Put them up. Let me see. Henry, yours is the wrong way, sweetheart. I can't see it.
Deep for Dr. by the way.
If you want.
Henry,
Henry, turn
rotate
it,
it.
friend.
There you go.
All right. So here's the thing. Kate, can I pick on you for a second? I was walking by, and you guys had that pretty picture, and you were getting frustrated by it. I think you were, because like you're like, but there are only two forces, right?
Yeah, we were trying to.
What? So what is that about? How are there only two forces?
There's no applied force.
Yeah.
No one's touching it.
Yeah,
Wait, it's still moving.
but it is still moving. A lot of times, ladies and gentlemen, a lot of times people want to put a force on it if it's moving. But really, C looks just like A. You've got the force of the earth on the ball, and you've got the force of the floor on the ball. And ladies and gentlemen, that is it. Those are the only forces acting. Even though this thing is moving. It's going, but it's moving at tell me about its velocity. It's a constant velocity. Okay? So it is not what? Not accelerating. No, I decided I can. Tell me about the net force. If I add up all those forces, what do they add to? 0. We doing okay? Go D. Do it. Draw D quick.
Force of heresy. Robbery.
Like when it comes
He's the only one that's applying the ball. So he's applying the force to decide the ball is
That's my hand.
Oh.
Yeah, I did. Did you not see me do that?
Label those forces. Let's see it.
What does A stand for?
What's the break?
Lives, yes. We did it. Okay. Yo.
So the question I'm gonna ask you.
Good job, Ace. Good job.
It's a crap.
Yeah, it was still an ellipse. Okay, now it's just a more pronounced ellipse. It's not a special.
I might call on you. Is that okay?
Yes. Yeah, because it's like how a square is a rectangle.
That's perfect. How are we doing, Casey? Okay?
Yeah.
All right, let's see them. Show me your boards. Let's go.
E for ellipse.
Wow.
Or the
All right. So I see 3 forces on all of these. Let me write them down here so I make sure I agree with you. So I've got the force of the earth on the ball. I've got the force of the floor on the ball. And I've got the force of Harrison. Which way is that one going? If the ball is moving to the right, then the force is going to the left. Okay, so now I have a question. And that's an applied force, right? So which way is the ball going? It's still going to the right, right? But tell me about its speed. It's slowing down, right? Velocity is decreasing. Okay. Now, this is an important thing to know. If I was going to describe a decrease in velocity, I'm going to call that an acceleration. I know people get mad at me when I say that. Deceleration is not a technical physics term. It's just a negative acceleration. You have positive accelerations, you got negative accelerations. A positive acceleration means you're increasing your speed. Negative acceleration means you're slowing down. Is the net force 0? Okay. One other question really quickly before we move on. I'm going to throw friction back into this situation. If I was going to draw a frictional force, which way does it go? To the right or to the left? What do you think?
Friction against what?
The friction, like against the floor, the ball rolling on the floor. Which way does it go? It goes the same way as Harrison? Yeah? Yeah? We think so? Why does it go the same way as Harrison? Because, what'd you say? It's moving this way, and friction always has to go opposite of the motion, right? Opposite of the motion. So if I wanted to include friction, I guess, then I would put the force of the floor on the ball, FF. Did you get that reference? Is that, yeah? All right. How are we doing? Are we okay?
For friction, can you say force of friction, or you have to say floor on ball?
So every time you label a force, I want you to tell me the objects that are interacting.
Oh, okay.
Every time, always, always, always. Sometimes we get lazy and want to write just FG and FN. And I'll be honest, I do that too. I want to just do that. But I really, really want you to focus on the fact that the force is an interaction between two objects, because that's super important. Okay? All right. We've got just a few minutes. I want to get started on this thing. I like charts. I like to try and organize what I'm doing in chart form. And I also really like to, when I'm giving you something that I would recommend you keep for a long time, I usually print it on bright or dark paper so that you can find it in your notes pretty easily. Hence the colors here, right? And hence the sheet here. So I would like for you to send one person from your table quickly up to come grab one of these and fill it in. It's not. I didn't put them on cardstock. I'm sorry. You can just reopen it.
Supposed to get for all of us. Oh, really?
Get it!
Aiden's like so anxious that I still is. You're like the hospital. Well, I hope you're there. I do too. And you guys.
All right. I saw it in here when you were in here. I didn't see it after you left. Sorry. All right, ladies and gentlemen. So, this should not take us a super long time because we've gone through most of this before, but I just feel like this is going to help us to kind of put it all together here. So we're going to list the forces we know. I'm going to have you put them in this order just so that they are kind of like organized kind of as we presented them, and then we'll fill it in. So the first force we're going to talk about is gravity. We can. You know what? I just made this like literally this morning. So if you want another column, maybe put it over here and say like the label. That's what I would do. I'm going to make that column right now. I'm going to say FG. We'll call it gravity. Which object is pushing or pulling in the gravitational force most of the time? It's going to be the Earth. What direction does the gravitational force pull? Down. I'm going to be a little bit more specific than that, though, because you have to be careful. If you have a picture of my Earth like this, and I'm dropping, or I have a frog sitting on a table over here, the force of the frog, or the force of the Earth on the frog now is going up this way, right? Yeah. So what's a more clearer way to say direction? Towards the center of the Earth. Yeah. So again, guys, please. Okay? It's not always going to be the Earth. Later on, we're going to start talking about, other planets and stars and things. But for now, we're going to talk about it in terms of the Earth. So we're going to say it's towards the center of the Earth. So we can adjust that, later on. But just for our understanding. How do you calculate FG? Remember?
9.81.
M times G. We can just friendly remind ourselves that G is negative 9.81 if you want to remind yourself of that. We'll get to know that a lot better soon. Okay? Is the force of gravity able to cause something to accelerate?
Yeah.
For sure it is. And then just so that we've got this in our head, just to remind ourselves, if you have an object, the force goes like this, the force of the Earth on the object. Is this system making sense? I hope that this organizational scheme is helpful for you. I think I like stuff like this, so hopeful it is good for you too. Let's do the normal force next. Fn. Should we do this all together? Would this be helpful? Yeah? Just keep going? All right. Object pushing or pulling? What's pushing or pulling? A surface, yep. So that could be a table, could be the floor, it could be a wall, okay? Some sort of surface. What direction does it push or pull? Always perpendicular to the surface. Is there an equation or a formula to tell us how big the normal force is? No. You need to calculate it using the F net equation. So I'm just going to say F net. I'm going to say use the F net equation. Okay? Will the normal force ever cause an object to accelerate?
No.
It won't. It won't. That doesn't mean that an object can't accelerate when a normal force is acting, but the normal force won't cause the acceleration. The diagram, so we've got our surface here, and the force is going to go like this, F of the surface on the box or the object or the whatever. Yo.
Cause a negative acceleration.
Yeah.
Opposite acceleration.
Like you said there.
Yeah. Hold on, let me think about that for just a second. I suppose yes, it would. That it would. So we'll say it will not. It won't cause a positive acceleration. Is that fair to say?
Yeah.
I just want to make sure though. We want to cover our bases here. Maybe I'm gonna go with it won't cause something to start moving. Is that fair? I think that's true. If somebody can come up with a counter example, please let me know. Okay, but I'm gonna say it won't cause an object to start moving if it's at rest. Is that fair? If you can think of a counterexample, let me know, please, because I think about things out to a lot of examples, but there's always more. All right, let's do the next one. The force of friction. Let's talk about friction. Let's do friction, then we'll be done for today. Stay with me. What's the object pushing or pulling in this case? The what? The surface again. The table. Or the floor. Or the wall. What's the direction? It's going to be opposite motion. We know that. And it's parallel to the surface. Yeah. I'm going to leave this box blank because we're going to talk about it tomorrow. Okay? Will it cause an acceleration? Yes. It's always going to slow something down, right? It won't always cause it to slow down, but it can cause it to slow down. Can cause an object to slow. And if this is the surface and it's moving this way maybe, or there's a force, it's going to be pushed back this way. Okay? We will continue with our list of things to do tomorrow. We'll still be ready for a test on Monday. I'm feeling like that'll be good. Okay?
Move your binder.
Don't lose this pink sheet. Don't do it.